keeping up with our motto, let learning be a joy and teaching a pleasure. Here we are with a remote teaching and learning process to bridge the gap. Happy learning, students!
Hello students. Today we are going to see the chapter from Science and Technology Part 1. Chapter number 3, that is Chemical Reactions and Equations. Students, this is the second part of this chapter. We have covered certain things in your first part. Let us recall those terms. The things which has been completed in part 1 are chemical reactions and equation. That is, what is chemical reaction? What are chemical equations? And the second thing, that is different types of chemical reactions. So these are the things which has been completed in part 1. In today's part, that is part 2, the topics which are to be covered are: first is factors which affects the rate of reaction, oxidation and reduction, and rancidity. Starting with the first part, that is factors affecting the rate of reaction. Rate of reaction means the speed of the reaction, and this speed of the reaction depends on certain factors. First factor is nature of the reactant. Second, size of the particle of the reactant. Third, concentration of the reactants. Fourth, temperature of the reaction. And the last part is the catalyst. So these are the five factors which affects the speed of the reaction. That means this factor can either increase the rate of the reaction or they can decrease the rate of the reaction. These five factors are nature, size, concentration, temperature, and catalyst. Let us see all these five reactions one by one with the help of certain examples. Starting with the first one, that is nature of the reaction. Nature of the reaction. Any reaction, the nature depends upon the nature of the reactant. If the reactant is reactive, the reaction will be carried out faster. For example, in a reaction of metal like aluminium and zinc with dilute hydrochloric acid, that means I have taken aluminium and zinc and I am reacting it with dilute hydrochloric acid. Aluminium being more reactive than zinc, the rate of reaction of aluminium is higher than that of zinc. That means the rate of the reaction increases if the nature of the reactant is reactive. If the nature is reactive, the reaction will be carried out faster. Whereas if the nature is less reactive, the reaction will take more time to carry out the reaction. The second factor is the size of the particle of the reactants. A simple example here is, if the reaction is carried out with the particles of smaller size, the reaction takes faster. That means smaller the size, faster will be the rate of reaction. Let us understand this with the help of an example. Here, take two test tubes. In one test tube, fill pieces of Shaba tiles. Shaba tiles is nothing but the white tiles which has been used. So take that tiles, grind that tiles in small pieces and take those small pieces in a test tube. Name that test tube as A. In the other test tube, fill powder of Shabbat tiles and name the test tube as B. In both the test tube, add some amount of hydrochloric acid. So what we have done is we have got two test tube. First test tube name as A, second test tube name as B. Your test tube A is filled with pieces of Shabbat tiles, whereas test tube B is filled with powder of Shabbat tiles. So in one test tube we have got pieces, in other test tube we have got powder form of Shabbat tiles. In both the two test tubes we are adding same amount of hydrochloric acid. Now here, since test tube B contains powdered form of Shabbat tiles, the speed of the reaction will be faster. So that's what is observed here. We will see the bubbles rising of CO2 from the test tube B rapidly than the test tube A. It's because the size of the particle was smaller in B than in A. That means the rate of the reaction increases if the size of the particles of the reactant is smaller. So smaller the size of the particle, faster will be the rate of the reaction. So we have seen two things. First was nature. In nature, what we have seen is the rate of the reaction increases if the nature of the reactant is reactive. Second is size of the particle. Size of the particle affects the rate of the reaction. That is, if the size of the particle is smaller, the rate of the reaction will be faster. The third factor which affects the rate of the reaction is the concentration of the reactants. If the reactant is more concentrated, the reaction will be carried out faster. If the reaction is less concentrated, reactant is less concentrated, the reaction will take more time. For example, take a test tubes, same as the earlier one. One is filled with dilute hydrochloric acid, name it as A. The other is filled with concentrated hydrochloric acid, name it as B. In both the two test tubes, add calcium carbonate powdered in both of them and observe the reaction. What we'll observe is we'll see the bubbles of CO2 coming out from the test tube B rapidly. Then test tube A. It's because the concentration of the reactant in B is more than in A. That means the concentration of the substance affects the rate of the reaction. The fourth point which we have discussed was temperature. Temperature of the reaction. Here we have taken some calcium carbonate in a test tube. Fit a bent tube to this tube with the help of a rubber cork. Insert the other end of the bent tube in the freshly prepared lime water. Heat the test tube containing calcium carbonate strongly. As soon as I start heating, the lime water in the other test tube turns milky. If in the same reaction heat is not supplied, then no reaction will take place. That is, the rate of the reaction increases if the temperature of the reaction is increased. That was the fourth one, called as temperature of the reaction. The last factor which plays a role in the rate of the reaction is the catalyst. Catalyst is a substance which by mere presence affects the rate of the reaction. That is, this is a substance which is added to carry out the rate of the reaction or to increase the rate of the reaction. But this substance itself does not take any part in that reaction. That is the speciality of the catalyst. For example, on heating potassium chlorate formula is KClO3. On heating potassium chlorate, decomposes slowly. You know what is decomposition reaction, which you have seen earlier. That is, it splits up. Now, if thus rate of the above reaction neither increases by reducing the particle size nor by increasing the temperature of the reaction. However, if the same reaction is carried out in the presence of manganese dioxide to liberate oxygen, then no chemical change takes place in manganese dioxide in this reaction, but the reaction is carried out faster. So here MnO2, that is manganese dioxide, is called as a catalyst. So what catalyst does basically is the rate of the reaction increases if the reaction is carried in the presence of a catalyst. So catalyst is a substance which alters the rate of the reaction by itself taking part in any such type of reaction. So these are the five factors which affects the rate of the reaction. The next type of reaction depends on the presence of oxygen or the removal of oxygen. Based on that, it is classified as oxidation reaction, and the second is reduction reaction. Oxidation, as the name suggests, oxygen, OX. This reaction, oxygen is added or hydrogen is removed. So reaction where there is an addition of oxygen or removal of hydrogen is called as oxidation reaction. Let us understand it with the help of these examples. First one, magnesium combines with oxygen and forms magnesium oxide. Magnesium formula is Mg, the oxygen is added in it, and we are getting MgO, that is magnesium oxide. So in this reaction, magnesium is reacting with oxygen and addition of oxygen takes place. Second example, in second example, ethane on heating gives you ethene. So ethane, the formula is CH3-CH3. Ethene, the formula is CH2 double bond CH2. That is, hydrogen is removed from it. So reaction where there is addition of oxygen or removal of hydrogen is called as oxidation. The next type of reaction is reduction reaction. Reduction reaction is exactly opposite to what we have seen in oxidation. That is, addition of hydrogen or removal of oxygen is called as reduction reaction. Example, magnesium combines with hydrogen gives you magnesium hydride. So here addition of hydrogen has taken place and we are getting magnesium hydride. Second example, silver oxide on heating decomposes into silver and oxygen. So in this example, oxygen is removed, so we called it as reduction reaction. So depending on the presence of oxygen and the absence of oxygen, it is classified as oxidation and reduction reaction. Ox reaction, the name itself tells us that it contains reduction as well as oxidation. So reaction which carries out reduction as well as oxidation, such reaction is called as redox reaction. A simple example is hydrogen sulfide combines with sulfur dioxide and gives you sulfur plus water. In this reaction, if you observe on the left hand side, from hydrogen sulfide, hydrogen is removed, and from sulfur dioxide, oxygen is removed. So removal of hydrogen, that is called as oxidation, and removal of oxygen, that is called as reduction. Since both the two reactions are carried out in one reaction, such reaction is called as redox reaction. The last term of this topic is related with a term called as rancidity. What is this rancidity? Rancidity. When we use oil, old leftover cooking oil for making food stuffs, it is found to have foul odor. That is called rancidity. Such oil is called as rancid oil. The process of oxidation reaction of foodstuffs can also be slowed down by storing it in airtight container. That is the reason when we take oil from the shops, you will see that the containers are closed. At the top of the box or the container, the seal is closed, because if it is left open, oxidation is carried out, and if it is heated for a long time, then to oxidation carried out. This process is called as rancidity. So that is about this topic. Thank you, dear students.